given this function, we're going to graph a transformation of it. So this is the function that we're given, and then we're asked to shift everything by this transformation. So first, let's make a table for the function that we're given. So I'm going to do x and y again, and I'm going to plot, or I'm going to use -2, -1, 0, 1, 2, and I'm going to plug those in. 3 to the -2, so I'll do it over here. 3 to the -2 equals 1 over 3 squared, which is 1/9. 3 to the -1 is 1 over 3 to the first, which is 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. So I'm going to plot these points. The first point is -2 and 1/9, which is very, very small. It's going to be super close to that x-axis. And then -1 and 1/3, a little bit bigger, not much. Then 0, 1, 1, 3, and 2, 9, which is just past my graph. So I'm estimating that it's about here. So I can see the curve. That's from this function. Now, what does this transformation mean? Well, we have to kind of think back about what we learned about transformations a while back, and that is if the addition or subtraction is happening inside, it's happening to the x, that's different than if it's on the outside. So let me explain the difference here. If I take my function, f of x, and I shift it, and I add 2 at the end, then what that's going to do, that would be like if it said this, right? That's how you know that it goes at the end, is if you take your original function and, actually let me call this something else. We'll call this, let me get rid of this. So here's our f of x. If I take f of x and I add 2 to it, then that means I'm putting a +2 here at the end. And that would mean that I'm shifting it up 2. If it were -2, I would be shifting it down 2. Now, what we've got in this problem is a little different. We're given this f of x, and we're asked to find f of x plus 2. That means that I'm adding 2 up here in the exponent. Instead of just having an x in the exponent, I have to change it so that there's an x plus 2 in the exponent. That's a different kind of shift. That's a shift from left or right. So that's the other direction, right? Instead of up or down, we're looking at left and right. And here, it works opposite of what you think. If you add 2 in the exponent, it's actually going to shift it left 2. So that means that we've got to take all of these points that we plotted and shift them 2 to the left. So let's do that. So now I'm graphing this one, and because it's x plus 2, that plus 2 is in the exponent, then I have to shift 2 to the left. So this one would go here, and this one would be here, and then here, and then here, and then here. So the green dots show what the shift, what it looks like after the shift. Oh, oops. That last one is a little out of place. Let me fix it. That last one should be right about here. So the green one is f of x plus 2, and the blue one, which I didn't connect because I didn't need to, that's not what I have to graph. The blue one are my original points from my parent graph. All right, so remember, when it looks like this, that's a move up or down. Up if it's positive, down if it's negative. When it looks like this, that means that we're adding or subtracting from the exponent, and that's going to be a move either left or right.